So we're going to look at this idea of doubling time, and we're going to practice more with it. So for this first one, I'm going to figure out the doubling time. And the doubling time is I'm going to go ahead and I'm going to start with 70, the rule of 70. 70 over the percent equals the doubling time. So 70 over 7 gives me a doubling time of 10 years. So I'm going to start with 100,000. I'm going to abbreviate 100,000 as 100K, K for 1,000, like kilo actually. And then that doubles to 200,000. And notice I'm not adding 100, I'm doubling. So 200 doubles to 400,000. 400 doubles to 800,000. 800 doubles to 1,600,000. But now I could be in the realm of millions. So it's going to be 1.6 capital M million. So again, knowing your thousands, your millions, and your billions becomes really helpful in this. And that goes to 3.2 million. So I'm going to have 1, 2, 3, 4, 5 doubles. Okay, so I have 5 doubles that happen. So I'm going to have 10 years times 5 doubles is 50 years. I'm going to add that to the base year of 2015, and I'm going to get the year 2065. So several steps to this problem. I first had to solve for the doubling time. Then I had to figure out 100,000, how many doubles it takes to get to 3.2 million, and that was 5. So I did 5 times the doubling time and got my 50 years. And then I had to add it to the base year of 2015. So 2015 plus 50 gave me the year 2065. For this next one, it says the population goes from 2 million to 16 million. So I'm going to just chart that out first. 2 million doubles to 4 million. Notice it keeps doubling. I don't add, so it goes to 8 million. Goes to 16 million. So I can stop there. It went through 1, 2, 3 doubles. So it has 3 doubling times equals 21 years. So I'm going to solve for x. So divide both sides by 3. And x equals 7 years. So 7 years is my doubling time. Now I have to use my rule of 70. 70 over percent equals doubling time, but also 70 over doubling time equals percent. So I'm going to use 70 over doubling time equals percent, or I could have just rearranged that previous equation, and 70 over 7 equals 10%. So my answer for that would be 10%, which is a really crazy high growth rate. But it makes our numbers a little easier to work with. So the next one, population has 100,000. In what year will it be 6.4 million with a growth rate of 0.35%? So I'm going to start with my rule of 70. 70 divided by 0.35%. Notice I don't change it and get rid of that decimal. I leave that decimal exactly as is in there, and I get 200 years. Okay, now I'm going to go ahead and I'm going to start with 100,000, doubles to 200, doubles to 400, to 800, goes to 1.6 million, goes to 3.2 million, and goes to 6.4 million. Okay, so again, my thousands to millions, make sure you're familiar with those. I go through 1, 2, 3, 4, 5, 6. I go through 6 doubles, so I'm going to have 200 times 6 is 1,200 years, plus the base year of 2015, and that's where I get 3215 in the year 3215. Again, it assumes everything else stays the same, and well, that's kind of a crazy assumption, but it's just a simple basis for it. Next one I'm going to do here is population goes from 2 million to 64 million. So 2 doubles to 4, doubles to 8, doubles to 16, doubles to 32, doubles to 64. And it's 1, 2, 3, 4, 5 doubles. 5 doubling times is 25 years. So when I solve for x, I'm going to get a doubling time of 5 years, because the doubling time is always the same. So I'm going to use my rule of 70. 70 over percent is doubling time, or 70 over doubling time equals percent. So I'm going to come plug this in over here. 70 over 5 years gives me a growth rate of 14%. In reality, you're not going to see something like that in population, but just gives you an idea. Easier numbers to work with. Last one, I start with 750 million, so this is millions to billions. That now doubles to 1.5 billion with a B, okay, or 1,500 million, but again, it's going to billions, so it's good to know my millions to billions, 3 billion, and then 6 billion. So I have that. I'm going to take my doubling time. 70 divided by 0.7% gives me a doubling time of 100 years. There's 1, 2, 3 doubles, so that's 300 years. So 300 plus 2015 gives me the year of 2315. So in that year. So that's kind of how I go about solving this.